And we're back. Okay, so Dana drew my attention on a few questions that I had missed, so I'm going to go back there before continuing here. So let's see. Maybe that was not the best thing. Okay. So yeah, good question. What triggers the Maven verify rerun if the POM XML file and the source folder have not changed? So the thing is that from the Docker builder perspective, the Docker builder doesn't know about the dependencies between the files. Maven does know. Maven would know, oh, that thing changed and that thing didn't change. So Maven would be able to be smart and to rebuild only what's needed. But if you take the Docker file, which is, and by the way, yeah, I'm going to share the Docker file with you. Tuk, tuk, tuk. There we go. So in that Docker file, you know, like Docker is not aware of the dependencies. So that means when I hit that point, copy ... then if anything has changed, we bust the cache, and that means we need to rerun everything after that. And when we run these commands, we remember my metaphor of it's like in a video game when you save your game and you restore later. What that means is that everything that we did after that, it's gone. So we go back to the point where we just had done MVN verify. So that's why when I change any file in there, it means that I will have to rerun entirely all the commands after that one. All right. Was there any other question that I missed? I think that's it, but if I missed one of your questions, you are more than welcome to re-ask it just in case. So normally I see them, but sometimes if it scrolls too fast, I might miss one. And Dana helps me by flagging the questions as well. And so sometimes so that you might have noticed like the little check marks, etc., that indicates when the questions have been answered and so on. But if I miss something, or if you feel like you want more details, absolutely don't hesitate to ask. It's also the whole point of having a live training, right? Because if you could not ask all the questions, and if I did not take the time to answer the question, I could just play a recording and play with the cats on that tree or whatever instead. Okay. Right, we have one more Docker file to write, one more component to containerize, and that's the database. And that one is going to be very interesting because it will be the opportunity to honor the work of the maintainers of the official images. And this is a really great team, by the way. It's often very, how do we say, ungrateful work. It's a little bit like package maintainers. Yeah, there are people who build and maintain packages for our Linux distributions, and we really can't thank them enough because it's not a very fun work, but somebody has to do it. And it's the kind of work like if it's done well, we don't notice, and if it's not done well, we do notice and we're unhappy. But just like open source maintainership in general, often we tend to complain when things don't work, but we don't realize like when everything works and the good works is invisible. So it's a good thing sometimes to remember that some folks worked really hard for that, and this is going to be a perfect example of that. So let's see what we need to do. DB, that's going to be the database for this application, and it's a Postgres database, and it must be initialized with a schema and with some data. All right, and the schema and the data have been put in words.sql. Okay, so I'm start to scratch my head a little bit and think, how am I going to implement that? Maybe I could start with Ubuntu, and then I could install the Postgres package, and then I would need to maybe, I don't know, I could run the container and then load the SQL file and then do a Docker commit or something like that, but it seems a little bit complicated. Now, that's where the official images are going to be amazing. Let's see the additional information. It says, we strongly suggest to use the official image. Okay, we can find it on the Docker Hub. It's called Postgres. And in particular, we should look at initialization scripts in the documentation. All right, let's look at that. Okay, so that's the Postgres image. All right. And we scroll to initialization scripts. Where is it? There we go. If you would like to do additional initialization, you can add SQL scripts in Docker entry point initdb.d, and basically they are going to be executed automatically. Well, it looks like it is exactly what we need. We copy the SQL file in that directory and it should run automatically. It seems a little bit too good to be true, so let's try. I'm going to copy the name of the directory to make sure I don't screw up. So from Postgres, copy words.sql to that directory. All right, now docker build .-tdb. Okay, now docker run db. And we get like a big error. It says, whoa, this is a security problem. It says, hey, you must specify a Postgres password, or you can also do blah, blah, blah. Okay, so what is this about? Did I do anything wrong? No, I did not do anything wrong. It's more like I forgot to do something right. I forgot to set a password for my database. And indeed, again, like if I read the instructions in full, it's going to, I think there is something, sorry, where is it? Here, it is advised to set up password authentication, but in this case, to make our lives easier, we'll simply authorize all connections by setting environment variable Postgres host of method equal trust. Okay. How do we set an environment variable? We have two options. Option number one, I put -e, like environment, and I put that on the command line. So I do this, and then it starts. Awesome. So that's option number one. Option number two, what if I don't want to put that -e on the command line? I can also put that in the Docker file like this, env, like environment, Postgres host of method equal trust. Okay. Now I build and I run and it works, it starts. Now let's take a closer look at what's going on here. So in the beginning, we have a warning because we used host of method trust, but that's fine. Blah, blah, blah. Then what is, so this is initializing the database. Okay. And then here you can see that the server started, database is ready to accept connections. And then you can see running words.sql. So it's creating the tables, it's inserting the data. And now that's very interesting. We see received fast shutdown request, shutting down. So it's stopping the database, and then it restarts it. So that's a little bit weird, but I'm going to explain what's happening here. If you compare, excuse me, here it says listening on Unix socket, var run Postgres, etc. So that means accepting connections, but only from this internal socket. If we compare to what we have further down, we have listening on Unix socket, but we also have listening on IPv4 and IPv6. So what does that exactly mean? It means that this image is going to start the database, but it will only accept internal connections, not connections coming from outside of the container. Then it will use this internal connection to load the database files like the words.sql, initialize everything, prepare everything, make everything nice. And then when it's done, it's going to shut down and restart, but this time it's going to accept connections coming from everywhere. This is a little bit like when you need to prepare a venue for an event. You're going to close the main doors and only have maybe the service doors open so that you can put, I don't know, like the tables, chairs, lights, stage, and everything. And when everything is ready, then you're going to open the front doors. This is exactly what this image is doing here. We start with only the internal access, and once we have loaded everything, we open the main doors, we allow connections from the network. So that logic, I think it's extremely smart, and that's in my opinion, a really good example of the work that goes into making official images. It's because there is if we had to do that, we could, but honestly, it would probably take me, I don't know, an hour, maybe a couple of hours to get everything right, read all the PostgreSQL documentation, to implement that kind of logic, etc. Now, here, look at how simple that ends up being. Just copy your SQL file in that directory and boom, it will automatically be loaded. I don't know if we could make it simpler, honestly. So that's just one little example of all the great work that goes into official images. All right. Well, so at this point, we have our 3 images. So that's it. Yay, victory. Do we have any questions before I move on to networking? Can we revert that environment variable after the image creation? Well, I could. Oh, like can I run that container but without that? Let's try. So if I do -e postgres host auth method equal, yep, I could do something like this to unset the variable. That would work. Yeah. All right. So now we're going to talk about networking. So when we want to connect to a container, we will typically need to expose that container. We also say that we publish the ports of that container. And I'm going to start with the hello world of network containers. And very often for that, we use Nginx. Nginx is a web server. It's pretty well known, and the reason why we use it for container demos, it's a little bit like for BusyBox. Like Nginx is pretty small, so when you want to do a quick demo, the image will be quick to download. It's not going to use tons of network and disk, etc. And out of the box, without any configuration file, without anything special, it's going to run a web server that will serve a static page saying, welcome to Nginx. let's see that in practice. So I'm going to do docker run -d because I want to put that container in the background. And then I'm going to do -P. So uppercase P, that's the same as --publish all. That means publish all the ports of this container, like expose all the ports of this container to the outside world so that we can connect to it. And then the name of the image, Nginx. So it's going to pull the Nginx image, and that's it. Now I have an Nginx container up and running. And if I do docker ps, you can see that in ports, before, ports was always empty. You know, like if I, sorry, tac, like this. You can see that for all my other containers, ports was empty all the time. But now we have ports 000049155380. Okay, what does that mean? It means that we have mapped that port number, like 49,153, has been mapped to port 80. And that means that I can connect to my Docker machine. So that's the IP address of the Docker machine. So I can go there on 49153, and that's going to show me the welcome to Nginx page. Okay, so there are some interesting questions here, like why 49153? Why not just 80? You know, like if Nginx, it's a web server, so this is HTTP, so by default it's listening on port 80. Why is it not directly on port 80 on my machine? Well, because we only have one port 80. So if I start multiple web servers in containers, the first one might be able to get port 80, but the other ones after that will have to get a different port. So to make sure that all my containers are equal, so to speak, you know, like there is no special treatment for the first container, they all end up on these high port numbers. Now, if I run multiple containers, same thing like Nginx and another one and another one. Now I do a docker ps. You can see that they have been assigned 49153, 49154, 155, 156, and so on and so on. Okay. So a very good question is, well, what if I want to decide which port I want to use? Like, can I bind a port to a local address? Yep. And yes, we can. And we're going to do that with lowercase p. And then we're going to put port on the host, colon, port in the container. So for instance, if I want to say port 1234 on my machine, so 45.33.8.47, I want that to go to port 80. Yep, I can do that. And now if I go to port 1234, I get welcome to Nginx. Another example, let's say I want to go to port 2345. Okay, so at the moment it says unable to connect. But if I run like this, so I say, okay, map port 2345 to the port 80 in that container. Now when I reload, it says welcome to Nginx. So this is going to give me kind of two techniques to expose my containers and connect things together. You know, first strategy, I use uppercase P, so I let Docker decide, I let Docker pick a port number for me, and then I check what was the port number and I put that in my configuration files, in my load balancers, etc., etc. Other strategy, I decide ahead of time, you know, I could make myself a kind of little mapping file where I say, okay, web front prod is going to be port 5000, web front staging is going to be 6000, and API prod is going to be 7000, and API staging maybe 8000, etc., etc. And then when I start my containers, I'm going to decide, okay, you use that port, and you use that port, and you use that port, etc., etc. So these are the two main techniques, but in practice, we will often use an orchestrator. So in practice, when we deploy a bigger application, we're not going to manually decide, oh, you use that port and that one, etc. No, the Docker networking is going to kind of concede. It's going to vanish in favor of the network mechanisms of Kubernetes or Swarm. So you might wonder, hold up, when we run in production, you're saying that we're going to use an orchestrator, and then we're not using Docker networking. So do we still need to learn about Docker networking? Yes and no. Yes, we still need to learn the basics of Docker networking, because when we run on our local machine with Docker, that's what we use. And that's what I'm going to show and teach you this week, basically. I'm not going to teach you the super advanced concept of Docker networking, because they will be, let's say, less necessary, but we're going to cover the essentials. Okay. So another little detail now is that our containers have IP addresses. So if I take that Nginx container B5F3, etc., I can do docker inspect B5F3, etc. Docker inspect, what does that do? Well, it's going to inspect the container, and concretely, it's going to give us a very long response in JSON. And this has like a ton of information about that container. And in particular, at the end, you can see we have an IP address. Okay, what can I do with that IP address? I can ping it, for instance. I can curl it, like I can access that container internally. Now, depending on how strong your network Kung Fu is, you may or may not know that this address here, 172.17, etc., that's an internal private address. Just like the addresses with 10 dot blah 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 or 192.168, all these are private addresses defined by, is it like RFC 1918 or something like that? But anyway, the private addresses that we use on local networks. So this is an address that only works from my Docker VM. If I take this and I go on my local machine here, that address doesn't work. By the way, generally what I'm going to do if I'm connected to the Docker VM, to the cloud VM with Docker and everything, it's kind of, I hope it's easy to recognize, because you have this special prompt with the IP address. You're going to see the yellow bar here for tmux, and I use a white terminal. And when you see the black terminal like this, you can see that I'm on my local machine. You can see that the host name is different. That's Raduga, that means rainbow in Russian, because it's funny to have a machine with Cyrillic characters. But that's kind of makes it easier to see what's going on, I hope. But so as you can see, if I try on my local machine here to connect to that container, it doesn't work, because this is an internal address. If I want to connect to that container, I have to use its external address and port. So I need to use this public address and I think I used port number 2345. There we go. So again, like if you, depending of how much experience you have with networking, maybe you're like, yeah, that's classic stuff, or maybe you're like, oh, interesting. But this is very similar to what you have if you, I don't know if you have done this before, but when you have internet, for instance, at home, and you're using, let's say, a cable or DSL router or something like that, you have your computer at home, and you cannot, if you are at home on your LAN, you can connect to that computer. Let's say that I'm putting up a small web server and I ask to someone next to me, hey, what can connect to that? They will be able to connect. Now, if they are outside of my home network, they will not be able to connect. If I want them to be able to connect, maybe I would need to go to my cable or DSL router and set up some port forwarding and get my public IP address, etc. Well, this is exactly the same thing happening here. My containers are on a kind of internal private network, and by default, we can't connect to them from outside, except if we publish, if we expose these ports. All right, one last thing, if I ping that container, and now I stop the container, you can see that the ping stops immediately. It's a kind of way to show, yes, this IP address is really the IP address of the container, because if I stop the container, the ping stops right away as well. All right. So that was really like the hello world of container networking, honestly. So with that, I would like to show you how we can get a local development workflow with Docker. Okay, so local development workflow. Let's imagine the following scenario. I just joined. I'm a new developer who just joined a new company. They are a web agency working on lots of projects for their customers, and this is going to be my first day. And I don't know it yet, but this first day is going to be very hectic. Before I see that there is a question on, is there a lightweight method to figure out the local IP address instead of an inspect? Excellent question. Well, I guess it kind of depends of what we mean by lightweight, I have one in the slides here. You can see like we have this Docker inspect -- format. So that's a way to extract a particular piece of information from the output of Docker inspect. So I could do something like this, Docker inspect blah blah blah, and that's going to give me the IP address of that particular container. So that's what I would use personally. Okay. So back to my little story. I'm a new developer in this new company. It's my first day. And so on the first day, my manager tells me, okay, I'm sorry, things are going to be a little bit hectic because we're busy with tons of stuff, but we need you to make some changes to an application that we made like a few years ago for a customer. I have good news and bad news. Good news, we have all the code and documentation and etc. Bad news is that the person who wrote the code left the company a few years ago and nobody knows how it works. So we hope that you can figure it out. And also, this is your brand new computer. Good luck. So I'm like, okay, thank you. So I was saying, okay, so I get my my new computer, and like, okay, where is the code that they promised me? How should I deal with that? I'm like, well, so the repo that you need to work on is github.com/jpetazzo/namer. this is the code. I'm like, okay, great. So I'm going to copy that, go to my brand new machine, git clone, and have a look at this application. So we have both like good news and bad news. Here, the good news is that we have a README file with some documentation, hopefully. We also have a Docker file, so that's great. We can build containers. Now, the bad news is that this seems to be Ruby. There is an RB file and there is a gem file. Why do I say that this is bad news? Nothing against Ruby, but I just don't know anything about Ruby, so I'm going to struggle a little bit with this. But okay, let's check the documentation. Well, that's helpful, I guess. So maybe we can try to build the container and run it and see what happens. At least we have a Docker file. From Ruby, copy this, work that, etc., etc. Expose. Okay. Oh, by the way, this expose here, this is so that Docker knows what's the port number that it needs to expose, that it needs to publish. All right. So let's try to build this. Docker build -t namer. This is downloading Ruby 2.1. And by the way, Ruby 2.1 is a super old version of Ruby. I think it's 7 or maybe 8 years old. So, you know, when they told me, oh, the person who wrote that code left a few years ago, I think by a few, they meant like maybe 5 or 6 years or maybe 7, because this is really like really old code. As an aside, this is a demo app that my coworkers at Docker wrote back in 2014, and I kept using it later because like that's a perfect small example for what we want to do here. Okay, so we built that container. Cool. Now let's run it and see what happens. Docker run -p namer. Okay. Okay, I was exaggerating a little bit. It's only 6 years old, 6.5 years old. Docker PS. Wow, that's a lot of containers. Okay, it's on port 49157. Okay, let's connect to that and see what happens. 49157, go. And that's the app. Each time you reload, it's going to generate a new name and a new bullshit tagline, basically. So you can be like Coop Inc. and synthesize turnkey paradigms or seize user-centric platforms, etc. Okay, I don't really know why our customer needs that, but apparently we developed that application from them a while ago. Maybe it's an hedge funds investment company and they are in the business of acquiring fledgling startups and then renaming them and changing them for the worse, which is what usually hedge funds do. So anyway, that's the app. So now, I mean, I got the app up and running, and I think that's already pretty nice because I don't know much about Ruby. I didn't need to know anything about Ruby. All I did was Docker build, Docker run, connect, and it works. Plus, this was using a very old version of Ruby, and I didn't need to think about how do I install that on my machine, how do I get that particular version. Of course, I could have used tools like RVM or RBenv or whatever, but I did not even need to worry about that. I'm just like Docker build, Docker run, and it works. Great. So I can get my laptop and go back to see my manager and ask them, okay, I got the app up and running. Now what should I do? What's the request of the customer? Well, the customer is doing a huge rebranding. They don't like the color blue anymore. So they would like us to propose, you know, a new design paradigm and new things, new colors, new whatever. Okay, perfect. So I go back to my desk and I'm like, okay, how are we going to change this? Of course, in this example, I'm doing something very simple, very silly, like just changing the color. But in a real world example, I would do like deeper changes about the layout of the pages or whatever. But I'm trying to keep things simple here because honestly, if I had to do some web front-end work, it would not look pretty at all. So, all right, how can I change the color? So I go back to this thing. Okay, let's just run that maybe. Okay, so first this is going to be the blue version. So I'm going to tag namer blue and I'm going to run namer blue. Okay, and I'm going to leave that running. How can I change the color of the text? Maybe in config? No, I don't know what this file is doing, but clearly it's not doing anything about the color. Where could it be? It seems to be blue, so maybe I could do grep blue star. In company name generator.rb. Yep, exactly like in the middle of the screen, right there I have color royal blue. So I'm going to change that to color red. And now I'm going to docker build namer red. It's reinstalling all the dependencies. It doesn't take 20 seconds like earlier with Maven, but that still seems to be a lot of time if I'm just changing one color in an inline CSS entry. So I wonder if we could optimize that. But let's do things like one at a time. Okay, I got namer red, so I'm going to docker run it in the background, publish all the ports for namer red. Now docker ps, namer red is on 49.159. Okay, so 919. Okay, it's red. Awesome. Now, of course, I'm not going to go in my customer meeting with just one example. I would like to give them multiple options so that they can pick the best one. So let's see. Well, first I want to solve that build time thing. So what's going on here? Let's look at the Docker file. We are copying all the code in /src, and then we run bundler install. Bundler install is the thing that installs the dependencies. So I would need to put that before, ideally. But to run bundler install, I need to have the file with the dependencies, and this is gemfile. So if you look here, the dependencies are in gemfile and gemfile.lock. Gemfile and gemfile.lock. Okay, so I'm going to copy that. Copy gemfile and gemfile.lock to the current directory. Then we run bundler install, and then we continue everything else. Let's build this. So it's telling me, hey, if you're copying multiple files, you need to put a slash at the end of that thing here. Okay, fine. So put a slash here to kind of indicate, hey, this is a directory. I mean, dot is always a directory, so this is kind of a little bit annoying that Docker tells me that, but whatever, I can put a slash, no problem. Now Docker build. So now it's doing bundler install, copying everything else. Okay, great. So now I have namer.red. So now I want to give other options to my customer. So maybe we also want some green. So again, I'm building namer.green. See how the build was super fast now? Great, we like that. Let's run namer.green. Namer.green is at port 49160. Okay, 49160. Great. Let's also give them a couple of more options like yellow, and also purple. Run the yellow and run the purple. And that went on the following port numbers, I suppose. 161, 162. Okay, you get the idea. Okay. So now I can go in my meeting with my customer and show them, okay, here is a few propositions for your new, how do we say, graphic identity. We have some red if you want, we have some green, we have some yellow, which as you can see is an extremely bad idea. We have some purple, and that's it. So again, this is a kind of simplistic example because I'm just changing the color, but keep in mind, this could be like way more complex changes, like way deeper changes in the application. Now, what's interesting is that when I walk into my meeting with my customer, I can show them all these versions in parallel. You know, I have the purple version, I have the yellow version, which is absolutely impossible to read. I have the green version, I have the red version, and so on and so on. I think that's very interesting because without containers, if I wanted to do that, let's think about how we would do that. You know, like if I wanted to show my customer multiple versions, the classic way of doing that is, well, I'm going to show you the first version. Now, hold on a minute, I'm going to deploy the other version. Now we can look at the second version. Now, hold on a minute, I'm going to make some changes and show you the third version, etc. Or we could deploy that, you know, on multiple servers or multiple environments. But here, I don't know what you think, but it was pretty easy. I just built a bunch of images, ran a bunch of containers, and that's it. Each container is on a different port number. I just connect to that port number, and that's it. And it's not using a lot of resources. Actually, you know, like the VMs that we use here have 4 gigs of RAM and I think like two CPUs. So they are really small VMs. I don't need to deploy like multiple servers, etc., etc. I can show this demo to my customer very easily. Okay, that's great, except when I make changes to my code, even if I optimize the build, the fact that I still have to build, run the container, find the port number, connect to the port number, that's kind of, I don't know what you think, but if you do web development, that's kind of annoying. I would like to be able to make changes, save, reload, and see my changes immediately, exactly like when we work in the local environment. So can we do that, and how? So yes, we can do that. And to do that, we are going to introduce something called volumes. So a volume is a way to take a directory on my machine and kind of share that directory with the container, so that if I make changes on my machine, the changes are going to be visible in the container. Okay, in concrete terms, this looks like this. So I'm going to do a Docker run, and I'm going to add the -v option, like volume, and I need to put a path, a local path on the machine. So path /path on machine colon path on container. Okay, so what exact path do I need to put here? Let's see. Path on the machine, so that's going to be the current directory here where I have the source code. So that's home docker namer. Okay, so /home /docker /namer. Now path on the container, where in the container is the source code? Well, it's in /src. That's what we did here. So /src, docker run for real, docker ps, and that's on 49.163. Okay, so now we go to 49.163. Right. Now, if I make changes, like purple, instead I want some, I don't know, cyan, which should be some light blue, reload, and up we see the changes immediately. I don't need to rebuild the container, start a new container, etc. I make my changes and I see the results immediately. If I want just plain black, reload, yep, that's black, etc. Okay, so this volume thing is going to give me a really efficient way to work on my code locally. Like here, I'm on a VM and I'm using Vim. But if you are on your local environment, you could use VS Code or IntelliJ or whatever editor or IDE you want, and you make changes, you save, and the changes are immediately visible in the container. Small technical details. This is not synchronization. You know, it's not like, oh, you save and it copies the files. No, it's more like the container is accessing the local files. So there is no delay. There is no issue like that. Now, let's see a little but interesting detail here. Let's imagine that the local cat, instead of hiding in that tree somewhere, goes to take a walk on my keyboard while I'm doing something else. And let's say that my cat even knows how to save in Vim. So I go back here for my demo with my customer and I do reload and then boom, error. And I'm like, ooh, that's bad. That's bad, but I still have my other containers that are up and running. So that's kind of interesting because it means that, remember I was telling you like how would we do that before when I want to do my demo, you know, multiple versions, show that to my customer? Well, typically we show one version and then we're like, okay, make some changes, show the other version, etc. And there is a risk here. Like, you know, what if it's taking me some time to switch from one version to another? What if I get something wrong? What if I accidentally delete the wrong file? Here, I'm kind of eliminating that risk because I have my code in a container, and it doesn't matter if I completely mess up my local environment. I still have that container. I can still run that container in a second and show that to my customer. So here, of course, the best is to go back to the code and fix the problem so that I can, so that I can reload and get it to work. But if I've severely messed up my local environment, I still have these images here. So it may or may not seem like much, but this is actually super powerful. This is the tip of the iceberg for two concepts called immutable infrastructure and blue-green deployments. Immutable infrastructure, what is this about? The idea behind immutable infrastructure is that you never make changes to an existing server. So let's say I have a server and it's running my code and I want to deploy a new version. traditionally, I would update the code running on that server. But no, with immutable infrastructure, I get a new server, I get the new version of my code on the new server, and when we're ready, I switch to the new server. So, like in theory, it sounds like an interesting idea. Okay, you prepare everything on the new server, you take your time, you double check everything, and when you're ready, you move to the new server. Now, in practice, it can also seem very wasteful because I need to have 2 servers instead of 1. So if my servers are like old school, like physical machines, it's going to be pretty expensive. Yes, but if my servers are virtual machines or containers, it's not going to be very expensive to run an extra virtual machine or an extra container. And in fact, it's going to be extremely easy. We just did it. We just implemented this pattern called immutable infrastructure right there in 20 minutes, 30 minutes, something like that. And that's particularly interesting because 10 years ago, when we talked about immutable infrastructure, it was it was same idea, but the implementation, 10 years ago we did not have Docker, so you could use containers, but typically immutable infrastructure was done with VMs, and concretely the only folks doing immutable infrastructure like for real at scale were big companies like Amazon, Netflix, Facebook, like folks like that. And to do that, they had entire teams of dozens, if not hundreds of engineers just to implement the immutable infrastructure. So the little thing that I just demoed in front of you here in half an hour with just Docker and me running commands, 10 years ago, you had complete engineering teams of extremely smart people doing like a lot of work just to give you the same ease of use, but with virtual machines. So for me, that's the interesting part in Docker. All the stuff about, containers and this and that, okay, fine, cool story. But for me, the really powerful part is that we can implement that kind of thing, that kind of pattern relatively easily. One solo developer can do that now, while 10 years ago it would have been so much work that only the biggest software companies were doing it. All right, so that's immutable infrastructure. There is also blue-green deployment. So I'm going to say a few words about that, and then we're going to, I'm going to maybe answer the questions, and then we're going to take the middle break. So blue-green deployment, the idea of blue-green deployments, it's very similar conceptually to this immutable infrastructure thing. The idea is that, again, when you want to deploy a new version, you have the blue stack, the blue version. So you have a bunch of machines that's the version blue, let's say version 1, and when you want to have version 2, so let's say green, you deploy a whole bunch of servers, so a completely new platform. So now we're not talking about just one machine, it's not just one machine and I switch to a new machine, it's a whole platform. So if my platform has 10 front ends and 5 API servers and 2 databases, etc., well, I just deploy the same thing, in duplicate, and when that platform is ready, we switch traffic. The advantage of doing that, well, there are many advantages, but one of them is that if we mess up, if we deploy to the new platform and we realize, oops, there is a pretty big bug here, you can roll back really easily because you still have your old servers here. So you'll just like switch back. If we had upgraded our servers, we would not be able to roll back that way. I mean, we would have to individually take each server and try to bring it back to the previous version. All right, so we have a couple of questions. You see, the other containers will not run without the volume argument. Yeah, so to be clear, we have 2 scenarios, 2 modes, if you will. If I want to deploy something and I want that to be, let's say, kind of stable. I mean, not stable as in software stability, bugs, etc. But I want to deploy something and I want that thing to remain as it is, immutable. Then I'm going to run without the volume. Now, if I'm in dev mode and I want to be fast and agile and iterate quickly, then I will use the volume. So it's two scenarios, two different workflows, without volumes, with volumes, depending on what I want to do. Next question, would the volume somehow be able to trigger parts of the Docker file? Excellent question. So we could do that with some extra work in the container. So in the specific case of Java, and disclaimer, I'm not an experienced Java developer, but what I've seen is a couple of interesting scenarios. I've seen one thing where you have your container running your Java app, and then you have a volume and you set up your IDE so that your IDE compiles and drops a jar file or a WAR file in the volume shared with the container. So that's one option. Another thing I've seen, because that thing works pretty well when you have a local IDE which you have set up, etc. But some folks tell me, well, cool story, but I don't have a local IDE. I'm just, I only work on this Java application very occasionally because it's part of this huge stack with many other things, and me, I work on the Python or Node part. I just need to run this Java thing. So what can I do? And what I've seen, another method, is that you have your container running, for instance, Tomcat, and then you have a separate container, which is a kind of live build container, so using something like Gradle, for instance. So I make changes to my code locally, and my code is in a volume shared with the live build container. So when I save, Gradle is going to detect this change and rebuild a jar file. And that jar file is then in a volume, which is itself shared with Tomcat. So at that point, things can get a little bit complicated. So I had some really interesting conversations sometimes around, hey, should we really do that? Is that the goal, like to have the whole dev environment in containers? Is that really, what's the advantage, etc.? One very important thing that I'm probably going to repeat at least one, maybe more times this week, is that the goal of containers is to make our lives as developers easier. So, I'm going to show you lots of tools and techniques and etc. Like for instance, volumes right now, or later we're going to talk about multi-stage builds and etc. And the goal is not to use that whole arsenal of tools and techniques. The goal is to make things easier for us. So for instance, if at some point you try to do something but containers kind of get in the way, it's totally okay to work locally or to use whatever else instead. When I work with Python code, I have a pretty rich Python environment locally. So when I work with Python code, very often I work locally. However, when I ship something for someone else, I try really hard to at least have a Docker file that works, because I'm a Python programmer. I know how to write Python code, and I know how to do some kung fu stuff with my requirements.txt and my dependencies and my virtual env and poetry and whatever. But maybe the person who's going to help me on that project doesn't know anything about Python, and they don't want to deal with all that crap. Instead, they want a Docker file, they want to Docker build, Docker run, and that just works. And I want to make that for them. I want to enable them to do that. Just like for my Ruby example, like for this little application, the person who wrote that, maybe they are a really good Ruby programmer and they have a local Ruby environment, even multiple local Ruby environments, and for them the container stuff is not even necessary, they don't need that. Great, but they still wrote a Docker file because they thought about everybody else, people like me who are not experienced Ruby programmers, and people like me want to just like Docker build, Docker run, and it just works. Maybe it's not the best way to develop on Ruby. Maybe an experienced Ruby programmer would tell me, you don't need that. Look, I can just use this and that and that. Great, perfect. They can do that. But for me, who once again doesn't know much about Ruby, it's awesome that I can have a Docker file and I can work on this application in minutes. So what I'm saying is basically, I'm not trying to tell you, oh yes, you should run everything in containers because it will always be the best option, etc., etc. No, sometimes it will be easier to work locally. But what I'm trying to say is that we should always have the container option because we should think about everyone else. I think it's one of the challenges when adopting Docker because the expert programmers, and especially when we got started with Docker, I had many conversations with really good programmers who were telling me, I don't need Docker because I can use this and this and this and this. And I'm like, yeah, cool story. You can use that because you are a senior programmer with 15 years of experience. Now, the rest of your team who are juniors just out of school, they can't use any of that. So you have two options. Either you spend 6 months teaching them how to use these tools, or you spend, let's say, 6 hours or 6 days or way less time to teach them how to use Docker. And well, very often that's what we do. So the key thing to remember here is that sometimes, like working in container is not the final ultimate goal that's going to make the experience nicer, etc. Containers are here to make it easier for the rest of the team, basically. And so if myself, I feel like Docker is getting in the way, it's fine at some point to just work outside of the box, outside of the container, if that works better for me.